We'll spend the next hour and a half having the breakout groups. We'll go in order here, having the breakout group leaders report back the way that we did yesterday. So we have a brand new board here, and I see the multidimensional folks already have their flip chart papers up there, so that's great. So we'll do this for an hour and a half, as I mentioned, and then we'll have a break and then general discussion. That general discussion is going to be fairly freewheeling, just trying to bring in and incorporate and move forward on all the various things that we've talked about over the last 2 days. There will also be some time for demos, sort of moving about, talking with your colleagues as you would like. We have a couple of our Esri ArcGIS for Maritime folks here who are going to do a short demo on their laptops for a couple of you who have expressed interest in that. We're going to try to give you information as best we can also about ArcGIS for ArcGIS Online for organizations. But for now, let's get started with the breakout groups. So we can start with the multidimensional data group, and there are 2 microphones as needed. So, Rich. Thank you.
We want to wheel this over there.
I think, Thomas, is this in the right position for the cameras? Oh, it is. Okay, you're all set.
All right. This is do you have to turn this on? Is that working? Hello, hello.
Oh,
okay.
there you go.
Well, I'm glad we're going first, because who could fall asleep after lunch talking, if we're going to be talking about NetCDF and HDF5. Okay, so we actually had a great group and had great discussion and flew through this. So the pluses for the multidimensional, oh, and I should say that we explicitly are talking about representation of multidimensional data in Esri. It could be much broader than that, of course, but we limited it to the Esri environment pretty much. Okay, so pluses. Well, there are NetCDF tools. That's a plus. The tools that are in there already allow you to simplify workflows. There's flexibility in how you can actually represent NetCDF once it gets in through rasters, tables, features. And it does take advantage of CF compliance in NetCDF, which is important because NetCDF by itself is sort of a low-level format, and it's CF which really turns that into more of a data model. The second one was that through the Python interface, you have access to a lot of other tools which can work with multidimensional data, and that's a big plus. And specifically, number 3 here, you can then use Python, particularly to access OpenDAP. I showed a little bit of that yesterday. So you have access to NetCDF from within the native environment. You have access to OpenDAP through third-party tools because of the interface in Python. And the fourth one is that there are improved visualization. I guess this could probably be expanded to be a little bit improved visualization of sort of 3D, 4D in a way. I mean, it's still 2D, but representing time with the time slider. There's sort of some initial steps towards working towards displays that work for multidimensional data. And the last one here, actually, it's sort of interesting in our group. There wasn't a whole lot of use of HDF, but the folks who had used it said that the existing tools work pretty well. So those are the pluses. So see if this works. Okay. Let's throw this on the ground. Okay, so moving on to the minuses. And as we've seen before in these presentations, sort of a lot of the pluses get reflected also into minuses. Like, it's great that it's gone this far, but could do more. And one big one is, the big one probably, is this a lack of a common data model library existing in a way that can be used inside Esri products. So there's no common data model library for Python. And so having this high-level API, it actually exists in other languages like Java, but we don't have it for Python. And so that's sort of like step 1. We don't have the API that can allow us to take advantage of these data models that the community has adopted through the CF process. So all those different kinds of data structures we've been talking about, there are standards out there, but we don't have the API. So we can't build the tools. Or we could build the tools, but the way to do it is through having a common API. Okay, so the second minus is, right now, okay, there's a NetCDF reader, and it uses CF compliance within that, it's sort of in the raster uniform grid kind of environment, but it doesn't support these other more complex data types. That's sort of a corollary of this in a way. And in addition, when we think about what we would need tools that could do things like, we've already talked about, like slicing into 3D volumes so you could do vertical sections, have vertical displays, do horizontal sections that actually have to cut through these sigma layers that are going up and down, following the water column. And right now, basically we have to turn everything essentially into 2D displays. Okay, so another minus, although this was a positive, the sort of in the extensibility through Python, much more could be done in terms of interoperability, or at least explored. And again, recognition that there is an API in NetCDF Java. Is there any way that that could be used somehow? We can't connect to that. We can't take advantage of that functionality in the current environment. And even though we can access OpenDAP from using third-party tools that work through Python, there's no native Esri support for OpenDAP at this time. And yet OpenDAP is the gateway to petabytes of climate, atmospheric, and oceanic data. So, and please jump, other folks from the group, I tend to forget things, so please jump in. Does anybody want to jump in now? Emilio.
Hello? Oh, okay. A question about the OpenDAP point that you make. If you are operating within Python, mixing ArcPy and Python in flexible ways, what exactly would you need from ArcGIS, from the ArcGIS API to support OpenDAP? If you don't have the API support for the overall data model, let me rephrase that. If you had support in the API for the data models, what need would you see to have OpenDAP be internal to the API?
Only one of sort of reliability, probably, because I think we might have this covered on a later point, but NetCDF for Python is a one-man show by a guy who develops it. It's not even part of his job. And so depending on something like that, may not be the best way to proceed. Although, it actually, so I think we get to that actually in the interesting part. So minus, it was, some folks in the group had noticed that there's, depending on the operations with NetCDF tools, there's some performance issues. So probably know what those are. And this one is, does anybody want to elaborate on that, or is that? Okay. And this one is, okay, so it says lack of NCML-like functionality to help ingest of non-CF compliant data. It's really, NCML is one way to approach it with this XML that Unidata came up with. It's basically how do you take these data sets, NetCDF, that maybe claim to be CF compliant but are not, or maybe they didn't even try. And if you have a model, a common data model, and you want to use the functionality of that common data model, how do you help users get their data into that data model? And actually NCML does things like aggregation, which can be very, very useful as well. You can take thousands of satellite images and represent it as one virtual data set. That's really, really useful. So how could we get that kind of functionality in for ARC users? And okay, and the interesting, so then we spent some time talking about, so how might you approach these different issues? And realizing there's tools out there outside the Esri environment, but maybe could be, we could be more interoperable with. One way might be, say, to think about, services instead of actually, trying to exchange data objects or something with Java. Say you could take advantage of Java by maybe building some lightweight services on top and then accessing those services. Actually, people already sort of do that when they throw all their data on a thread server and then access it through OpenDAP, things like that, but maybe something much more lightweight. And then this issue, like this is sort of getting back maybe to Emilio's question, where to provide the functionality. Should it actually go into the internal Esri ArcPy? Is that where it should go? Or if you're going to build an API that could be used by the whole community, maybe, there's lots of things you can do with a common data model that aren't necessarily just strictly GIS work, right? So maybe that should go. Maybe, Esri could work with others in the community, maybe, to build an API that folks could use in Python no matter what they were doing, and Esri users could use it also. That might be interesting. And actually, I think Jim brought this up about, one interesting way might be to, if you thought that Esri felt like they were too big to, that people would feel like squashed by them, you might even think about like starting up a little, you could start up a nonprofit essentially and allow folks from Esri to work for the nonprofit and, sort of help the standardization or development in a way that might be sort of more community building rather than threatening or something like that. Is that it? Oh, we have, okay. And then just a couple more interesting points. Some people weren't satisfied with 3 or 4 dimensional. Hey, let's think n-dimensional. And there was an example of a 300-dimensional data set brought up. And yeah, it is worth thinking about. I think maybe to make sure you're not boxing yourself into a corner when you implement your 3D or 4D data model. And one simple example of that is, say, something like an ensemble from an ocean model where you have 7 different initial conditions or something. This happens all the time in the environment, right? You have the same model, produces the same 4 different simulations, and you want to sort of do some statistics across those ensembles. This one I think is pretty interesting too. It's we were talking about these these multidimensional data models, but really when we saw the Arc Marine overview map yesterday, at least the concept map, there were slots in there for multidimensional data. So how does what we're talking about here relate to Arc Marine, and how does that also relate to the internal data model that's currently used by Esri? So that's an interesting one, okay? And then finally, just to note that around the world, there has been a lot of synergy around CF, and that CF has grown from some attributes for NetCDF files to make them more interoperable to a real data model that can be supported by NetCDF, can be supported by OpenDAP, HDF, and so it's really at a higher level, and there's been a lot of it really has become the international sort of de facto standard for this kind of data. And does anybody want to add anything? Okay.
Questions? Okay. Thank you, Rich. I'm sorry? Well, if you have questions about anything that Rich just outlined, there's time for questions also. So Florence has a question here.
Just for the record, what does CF stand for?
CF is the Climate and Forecast Conventions. It actually came out of the climate community. Obviously, they had a huge need, with all the different IPCC models to come together and have a. Actually, they moved from their old style interoperability was put everything on the same grid, right? And they realized that for the next round, they want everything on the native grid, and they want to be able to describe that in a common way. And so that's where those conventions came from. But it turns out, it's kind of, we were discussing yesterday, I think Tiffany mentioned or something, that it's really, those conventions turns out work equally well for us in the ocean. So we just adopted them and added a few more vertical coordinates and things like that, and they work really well.